This is question number 10 from the Fall 2013 Algebra 1 sample materials. On the set of axes below, graph the function y is equal to the absolute value of x plus 1, and then we have a graph to graph it on. State the range of the function and state the domain over which the function is increasing. Let's start with the first part. We want to graph this function. To do that, we need to make a table. There are two ways we can make the table. We could either do it by hand, or we could do it on the calculator, and we'll do it both ways. So this will be our x value column, this will be our y value column. Absolute value of x plus 1 is equal to y, and then we're going to plug in our x values and see what the corresponding y values are. So we have to choose x values. We notice that our minimum x value on the graph is negative 10, and our maximum x value is positive 10. So we really have to plug in all of the values, all 20 values between negative 10 and positive 10. But we won't do that here. We'll just choose, let's say, 6 and do those. Say negative 3, negative 2, negative 1, 0, 1, 2, 3. We'll do 7. We'll have some negative numbers, some positive numbers, and we'll have 0. So wherever we see an x, we're going to plug in negative 3. Negative 3 plus 1 is negative 2. The absolute value of negative 2 is positive 2. Negative 2 plus 1 is negative 1. The absolute value of negative 1 is positive 1. Negative 1 plus 1 is 0. The absolute value of 0 is 0. 0 plus 1 is 1. The absolute value of 1 is 1. 1 plus 1 is 2. The absolute value of 2 is 2. 2 plus 1 is 3. The absolute value of 3 is 3. And 3 plus 1 is 4. The absolute value of 4 is 4. Let's graph these 7 points. Negative 3 comma 2 is over here. Negative 2 comma 1 is over here. Negative 1 comma 0 is over here. 0 comma 1, 1 comma 2, 2 comma 3, and 3 comma 4. So your function looks like this, and of course you need to put arrows on both ends because to show that the graph keeps on going on and on and on like that, and it keeps on going on and on and on like that. On the Regent, you'll probably want to do a few more coordinates. It probably wouldn't be necessary to do all of the negative x values and all of the positive x values, but it would be a good idea to do a few more than these 7. But this is basically how the graph would look. If you didn't want to do all that manually, it wasn't such a hard one, but let's say you didn't, you can graph it on your calculator and y equals. You would click the alpha button. Notice it's in green. So when you click on the green button, you're really activating the little green letters above each button. And when we press window, you're in the F2 menu. The first thing in the F2 menu is ABS for absolute value. Press enter. And then type in your function, x plus 1. And zoom 6 for zoom standard, because notice that in zoom standard, your maximum x is 10, your maximum y is 10, your minimum x is negative 10, your minimum y is negative 10, and the same thing on the graph they give you on the Regent. But how does this really help you if you don't know the exact coordinates? If you press the second button, notice it's in blue, you're really activating the little blue words above each button. And if you press graph, you're in the table. And here you'll see the exact table that we just made, and you could really just copy these values. You would probably want to draw a short table, x and y, and then just copy over your values over here, just to show them which values you graphed, and then you could graph the same thing we just graphed. Let's move on to the next part of the question. State the range of the function. Now, if you look at our graph that we just graphed, this graph is never going to go below the x-axis. We're never going to have anything where it's yellow now. It's only going to go above the x-axis. That means that our minimum y value is 0. And notice that it keeps on going on and on and on, up and up and up, in both directions, keeps on going up. So the range of this function would be all y values that are greater than or equal to 0. Next part of the question, it says state the domain over which the function is increasing. So notice on the graph that we drew, the graph goes down, 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 down like this until it reaches this minimum point over here, and then it starts going up. The x-coordinate of the minimum value is negative 1. That means that it's increasing every x value that's greater than negative 1, which means that x is greater than -1 is the domain over which the function is increasing.